everyone, welcome to sigfigs. I'm doing this just before class, so hopefully people don't walk in, but if they do, I'll just hit pause. But sigfigs has 5 different rules, and they're important because we use sigfigs for things like scientific notation. We use sigfigs for precision and accuracy, which you learned about in the notes just before. If you haven't read those, I highly suggest going back and reading them because it's kind of a bit of a precursor for this one. So rule number 1, any non-zero number, so non-zero, so integer, which is a really fancy word for saying number between 1 and 9, right? So 1, 2, 3, all the way to number 9, right? They're always significant, are always significant. I highly suggest you write down the notes, because when you write down notes, you can you tend to remember about 20% more after you write down the notes. So an example of number 1, and I'm just going to take this and I'm going to erase these. There are 5 rules, but we'll do one at a time. So a quick example of this, we're going to change the color. Here's my example. So if I had a number like 1.237, the number of significant figures here, and significant figures, if you haven't watched the other videos, they are numbers that are significant. They're not placeholder numbers, they're just straight up really important numbers. So the number of significant figures here are sigfigs for short, because we're physicists, so we like to shorten things up real nice. There's 5 here, right? Because that's not a 0, that's not a 0, that's not a 0, that's not a 0, and that's not a 0, and there's 5 total numbers. So my sigfigs here is 5. This is as easy as it gets, rule number 1. Okay, rule number 2, any zeros between, so zeros between, I'll have to apologize for my chicken scratch, that's not the best, between any integer are significant. So an example of this, and let me just change the color real quick. There's the color. My example of this one is, say I had 1.20301. These zeros are also significant because they're not a placeholder, they're an actual number, which means that it just happened to be the actual precision or the accuracy, no, it'd be precision in this case, the precision of this number came out to be 0. So like that's when you kind of like look at the clock and you're like, oh, it's 2 o'clock on the dot, right? So those are significant. So if we count the number of sigfigs here, we have 1, 2, 3, 4, 5, 6. So my sigfigs here equal to 6. So that's rule 2. Rule number 3 is following zeros to the right of non-zero numbers are not significant. So what this means is, so let's write this out. So following zeros to the right, very important, of non-zero numbers are not significant. They're straight up placeholders. So an example of this, if we look for an example, oh, it's blue, I want red. My example for this one is this, hang on. So my example is 200. right? Think of it like chopping wood or something like that, and they say, okay, well, I need 200 inches of wood. That's pretty rough estimate, right? The 2 is significant, but these numbers here are not. They're just straight up placeholders. So in this case, the number of sigfigs is equal to 1. Now, there is a bit of an exception. Say I had 200 with the decimal place there. This decimal place makes it so that this and this are both significant because, hey, this is a decimal place here, it's showing precision. So in this case, sigfigs equal 3 because of that decimal place. Right there, that's really important. Where's my mouse? So let's write that quick exception. The quick exception is with the decimal, they become significant. So let's just write that. So with decimal, they become significant. They're no longer just placeholders. Okay, awesome. So those are the first 3 rules, and stay tuned for the next video for the next 2.